Hello, this is the Fusion team. We are researchers at the NetMod lab of ICCS, and we are presenting Fusion, a platform extension that is among the projects selected for the second open call of IMAGINE-B5G. Fusion uses the Norwegian facility of the IMAGINE-B5G project to integrate its software solution with the overall IMAGINE-B5G architecture. In this video, we will demonstrate the project, its implementation, onboarding, and validation activities. So, let's dive in.
The Institute of Communication and Computer Systems of the National Technical University of Athens is the research branch of the School of Electrical and Computer Engineering of NTUA. Established in 1989, it is organized into various cross-disciplinary thematic research units, one of which is the NetMod Laboratory. NetMod is pioneering interdisciplinary research across a wide range of fields, including mobile communications, edge cloud computing, resource allocation, service orchestration, semantics, interoperability, dynamic systems, and more. Modern B5G and 6G networks raise the challenge of bridging application-level workflows with underlying infrastructure resources across cloud, edge, and extreme edge environments. While applications generate logs, traces, and metrics tied to service workflows, the infrastructure exposes its own independent telemetry. Without a unified observability and fusion layer, it is difficult to correlate failures or performance degradations in the infrastructure with their impact on end-to-end service execution. Specifically, the objectives of Fusion were to develop a data model that unifies observability signals from applications, computing, and network infrastructure, build an open-source observability and analytics framework using established platforms and tools, ensure interoperability with external tools and AI models via standardized interfaces and APIs, provide a fused view of distributed applications and network functions to optimize performance, energy use, and system health, and leverage fused data for intuitive analytics to detect, explain, and mitigate failures. These objectives were translated in the Fusion architecture, aiming to provide a standardized way for collecting observability signals from services and infrastructure, analyze the provided datasets, and provide a set of fused models to external services and AI models, expose the raw and fused data through a set of well-defined APIs, consume the data to provide advanced analytics and orchestration services, and visualize all these features to enable network operators to personally identify and resolve issues. The Fusion platform extension was successfully integrated into the Norwegian OpenShift facility, where the core services of the framework, their respective APIs, and visualization dashboards were deployed. Telemetry signals were aggregated, processed, and exposed via REST APIs, enabling interoperability with external tools and applications. Data collection was achieved through distributed Fusion agents, leveraging OpenTelemetry and Prometheus exporters to gather metrics, traces, and logs from both infrastructure and applications. Integration tests confirmed IP connectivity and established ongoing data collection from two different data streams, each requiring different configurations of the Fusion agent, acting either as an OpenTelemetry proxy or as a Prometheus data puller. Validation activities focused on assessing the framework's ability to unify heterogeneous telemetry sources, execute AI-driven analytics, and support closed-loop orchestration at scale. Experiments were conducted using realistic cloud-native deployments, where Fusion ingested large volumes of metrics, logs, and traces from distributed services through OpenTelemetry collectors and Prometheus exporters. The framework was validated in terms of scalability and performance by stressing the data ingestion pipeline and measuring latency, overhead, and data freshness under increasing load conditions. AI-based anomaly detection and root cause analysis were tested with injected failures, allowing evaluation of detection accuracy, false positive-negative rates, and time to mitigation. In addition, closed-loop orchestration scenarios were validated by measuring automation gains, comparing manual versus AI-assisted remediation. These activities confirmed Fusion's effectiveness as a modular, extensible, and high-performance observability framework suitable for beyond 5G facilities. The IMAGINE-B5G Norwegian facility has been essential for Fusion's development and validation. It provided the OpenShift-based infrastructure, computing resources, and remote access needed to deploy the framework at scale. These capabilities enabled us to test under realistic conditions, integrate seamlessly with facility workloads, and validate Fusion's analytics features with real metrics. The facility's support environment further ensured smooth experimentation, making it a cornerstone for the project's success. In summary, Fusion aims to inject automation and intelligence into orchestration with a next-generation observability framework, shaping the way forward for 6G services.